So I've been wondering what I want to do with this web app that we've been working on for some time now. I wanted to turn it into something that, if you're a new programmer and you need projects to show for your future employment or whatever the case may be, some kind of portfolio or whatever, I wanted to maybe make something that you can add to that if you would like. And what I came up with was we are going to make a web application that users can create an account and write reviews for video games. Just as in Steam, if you've ever used Steam before to play or purchase video games, you can see reviews written by other people. So we're basically just going to use that aspect and make a web application with it. I figured this would be a good thing. Even if you don't want to put in a portfolio, it'd be a good way to learn for both you and I. As you know, I'm just as new to this as you are, and as I discover things, I present them to you. And so I figured that would be, since we're, already on the topic of video games and all of these videos so far, why don't we just continue with that? And so in this video, I want to talk about how to hash passwords in Python. And the reason being is we're going to, in the next video, this is probably going to be a two-part because I like to keep these videos a little bit shorter. And when we have users create their own account, we're going to be hashing those passwords. Because what if someone uses SQL injection, just as I showed you in one of these videos, this one right here? Or what if someone somehow gets into our database and sees our users table, right? We want to have those passwords jumbled up in some way that it's not understandable to the hacker. Okay, so what does hashing look like? And I have some tabs pulled up in which I'm going to show you some things as we go along, and hopefully they help you learn what we're going to do. So this is what hashing is. So let's say my password is password, and this is using the like SHA-1 or something. No, this isn't it. This is the SHA-1. Sorry. This is something else that is going to go along with it. But let's say my password is just password, and we hash that with SHA-1. This is what it'll end up being. Okay? And so that looks a little bit less understandable after it goes through some algorithm than me knowing what the original password was, right? I am not going to get from this that the original password was password. However, there are these things called, I think they call them rainbow tables. And basically it's people type in, every password that they can think of or every string that they can think of and hash it and take the result and make a table out of that. So they have the before and after. And now with that, I can take this hash and I can put in something like this. I gotta click I'm not a robot. And it'll tell me, oh, it found out what this was by just looking at it in some way. And the type was SHA-1 and the result was password. All right? We don't want that. So how do we prevent that? Well, we do something called salt. And all salt is basically adding a few extra characters into our original password. So that when it hashes, it comes out completely different than just the base algorithm. Okay? So this is the most basic diagram that I could find, but hopefully it makes a little bit of sense. And then what we're using to hash our passwords is this passlib.hash.sha256 underscore crypt. And that actually automatically salts our password, as you can see. And then we can use something called verify, where we compare, the hash value with the password, and we can see if it is correct. And I'll show you all of that here in 1 second. So what I'm going to do is I'm going to pip install passlib, if I can type. Don't mind all this red stuff. Let's just clear that. That's hard to look at. There we go. So now we have that installed. And just for the sake of demonstration, I am going to put this all in a new Python file. And it might help if I do the right extension. So let's rename that .py. There we go. And then what we're going to do in part 2 is I'm just going to take what we code in here and make it into a route with a user interface to create, new user accounts. Okay, so from passlib that we just installed, .hash, I am going to import SHA-256 underscore crypt that we just saw in the internet browser. Okay, and with this, that's basically all I need to hash our password. So let's say I have a password, and it's going to be basic enough. It's going to be password. Please don't use this password for anything. I can't imagine how many people actually do. And then just to hash it, we do SHA-256 crypt dot hash, and then we pass in what we want to hash. Okay, so let me put that in a variable, hashed password. And now I am going to print hash password. Okay, so let's go ahead and run this password.py. We're not in the right directory, are we? So let's cd into Python. And now Python password. There we go. It did nothing. Why did it do nothing? Oh, I didn't save it. There we go. Cool. So that's our hash password. So now if I take this and I copy it and I take it to this rainbow table and I type I'm not a robot again and crack it, you can see that it is unrecognized because of the salt. And then also notice something interesting. If I run it again, it comes out completely different than what it was. Pretty amazing. And so what we can do is we can actually compare this with the original password using the verify method. So if we do SHA-256.crypt.verify, and first one is the password, which is password, and the second one is the hash. So that would be hash password. And now if we save and run that, you can see that that now returns true, because this and this, after hashing this, is the same. It doesn't go back and decrypt this hash password. Once it's hashed, it's hashed. There's really no going back. So what it does is it hashes this and then compares the two. Okay, so what we want to do now is create our users table for our web app. So I'm just going to name this users. And the first column is going to be our ID, just like our games table. And it's going to be private key and auto increment, because that made our lives a lot easier, as you know if you paid attention to my last videos. And then we can do the user's name, which is going to be, whoops, it's going to be text. And yeah, we can make it not null. And then username, which is going to be not null and unique. Whoops. Yeah, that was unique. Okay, not null, unique. And not integer, it's going to be text. And the reason I want it unique is we don't want more than one user with the same password. They can have the same name, right? They can have the same name, Joe or Karen or whatever. But we don't care about that. We care about if they have the same username, which we don't want. And then I'll likely add to this table in the future with another column or so. But for right now, this is all we really want. Oops, I forgot the big one, which was password. And that's also going to be text, not null. And that looks good. I think we are okay. So now if we look at our table, we are ready to go for the next part, where we'll create a user interface, a little form. They enter all their credentials and all of their info, and we create an account for them. And so that will be part 2. Hopefully you guys enjoyed this video, and I hope to see you in the next one.